We have selected values of the derivatives of the twice differentiable function h in the table below. Okay, we have done a previous problem that was similar to this, and the problem said all the possible values of 0 for the derivative are listed. They never tell us that here. So we don't know what exactly happens around some of these points. This is positive and this is positive, but maybe right up next to it they are negative. We don't know. This is all we know, okay? So we have a twice differentiable function. We could take the derivative a couple times, and the derivative exists at every possible point. Choose every correct statement. Okay. Fun stuff. H has a relative maximum at 3. I'm going to just skip through here. H has a relative minimum at 3. It can't be determined if it's maximum or minimum at 3. So only one of those 3 is true. Okay, and we're going to do the same for 1 and for -2. Okay, so let's jump to 3. As the sun shines in the window and glimmers and makes you think of tropical breezes. So at x equals 3, we have where the first derivative is equal to 0. Okay, so far we are in a situation that is characterized like this. First derivative equals 0. And then the second derivative is positive. First derivative is 0, second derivative is positive. So what we know for sure is that in the general vicinity of this 3, how narrow is the window? Is it from 2 to 4, or is it even skinnier than that? I don't know exactly what happens as we get closer to 3, but what I know is the derivative at x equals 3 is 0, and the second derivative is positive. We're in this situation. Therefore, 3 is a relative minimum. That means we have a relative minimum at 3, and if you want to just uncomplicate your life by marking out the things it won't be, you can do that. Okay, let's talk about what happens at 1. At 1, we have a second derivative that is equal to 0. Okay? Dun, dun, dun. Sorry, first derivative equal to 0, and a second derivative equal to 0. Second derivative test fails, and we really don't know what happens there because we don't have other information. So it can't be determined. So that is the case here. We'll mark that out. Now, I have said in a previous video that it means neither, but we don't know enough information to really say a lot of things about this because, again, this is very incomplete. All right, what happens at -2? First derivative equals 0. Second derivative is negative. We're in this situation right here. We have a maximum. We have a maximum, and it's not a minimum, and we can determine it. There we go.